We'll take you through a bit of the user interface, then we'll show you some of the application pieces. We'll take you through how we could potentially build this from a REST API, so we'll show you the REST APIs. So I've got here 2 volumes, and this is actually built on top of vSAN. We'll talk a lot about vSAN. So I've got 2 environments, one built on vSAN that's going to show you really a consolidation piece, so a number of different servers consolidated onto one volume, and then also a performance piece, so with SQL, and we'll show you some clever stuff we can do with changing the amount of I/O that's available to an application. So here you can see, if I go back to vCenter, I've got 5 or 6 different servers running on top of this ADS volume inside my vCenter array. So I've got a mix here of Linux and Windows workloads. It could be a test dev environment, for example. And I'm really looking at the level of consolidation I get. So even for a relatively small number of virtual machines, I'm actually getting very good levels of deduplication, between 86 and 93%. Now, yeah, as more unique data comes in, that'll drop slightly, but we're still seeing, a lot of the work we've done is to optimize the I/O engine really for small scale number of virtual machines, because we're not going to see the hundreds of VDI sessions that we're seeing. It's going to be much smaller.
Application is global
it's at the ADS.
level?
It's at the ADS volume level. Okay. So it's happening as soon as we hit the first bit of virtualization within USX. So here you can see that I've got a hybrid volume, so we're taking a small amount of memory and aggregating resource from, in this case, commodity hardware. So I've got some Supermicros, and I'm taking a portion of RAM from that and combining that into a pool, a memory pool.
Can you lay out what you defined as a small portion, just so we know what ratios we're looking at?
I'm talking, well, I've built a pool here with 150 gig of memory,
Okay.
But I'm consuming about 24 of that for this ADS volume. And
sorry, one quick question as well.
Sure.
What's the overhead on the CPU side for running? Like, effectively, there's going to be, hopefully nominal, but
yeah,
like up to 10%, 5%.
Around 5%, up to that. So, and what we're seeing is, as we start, again, it'll come down to the scale that you drive this to. So, if I have extremely high I/O performance, I may burn a little bit of CPU. But it all balances out with what you're saving at the storage level and what you're giving the application. So it's that balance. You don't get anything for free, right? You'll burn something somewhere at some point. So here, yeah, I've got 150 gig. Now the key here is that I can actually have, say, hundreds of aggregators that are pooling RAM into one pool and then dish that out to different applications. So the application becomes the defining requirement for what my storage volume should look like. I've then got a capacity pool. My capacity pool in this case is bringing vSAN in as shared storage, and so I'm getting very good consolidation on top of that in an environment with mixed workloads. Now if I look at we talked about how we can build some of this stuff, so we can use this UI to come through and build pools, build volumes and everything else. We've also got REST API, which is fully accessible as part of the product. So it's not a separate download or anything else. And so you saw the 2 pools that I had before, and you can see that we have standard get and put and post operations as part of a REST API. So if I just go down here, I'll show you a very simple one that actually returns some data. In fact, if we try this out here, then you can see that I get a JSON object returned with all of the information about all of my pools. So now I can start to plug this in and drive this from a VCAC or a cloud stack and look at pools and what's happening with the pools and drive different behavior. So now I might decide that my pool's filling up and I need to create some more pools, so I can add or remove. I've actually got this deployment services module, which has a wide array of calls into it. So I can actually then start to build it. So this is the piece that's actually going to go and say, here's the information that you need to go and be able to build a new pool or build a new ADS volume.
And this is the same as the ILIO DS for which you use for ILIO, right?
So this, yeah, we took that and extended it for USX. So the key thing about USX is it's building on the technology that we've had in VDI for a very long time. So that deduplication, the provisioning, the deployment tool set is all now built. The difference here is it's inbuilt into the management piece, whereas that's a separate tool. Okay. So now I can start to look at I've also got another environment here, which is my SQL environment. So again, I've got a couple of volumes, capacity pools, some aggregators bringing in local resource. So now I'm starting to build an ADS volume from local storage, again using Supermicro. It's the majority of my kit within a test lab, and take RAM and that and deliver a hybrid volume. So we're still using hybrid volumes for this. And here, somewhere I've got
Do you have to manage it through your own GUI or your own web client?
Nope. So there's a complete the REST API that we showed you.
I don't know, but is it integrated into either the vSphere web client or, well, unlike some stuff, or the actual traditional VI client?
So at the moment it's separate.
Okay.
It's our management platform for carving out and creating volumes and everything else. Now it wouldn't go into vCenter. It doesn't make sense. It would make more sense to tie it into VCOps or VCAC or Cloud Stack, so an orchestration engine above us rather than vCenter, for example.
We do have VAI underneath it.
Yeah.
So it's exposed as a VAI-enabled data store. So from that standpoint, it's all offloaded down to us. There's one more piece I want to talk about, but I just blanked. Yeah, we have the console. I think I'll come back to it. I just blanked. Sorry.
You touched on OpenStack earlier, and you talked about Cloud Stack just now. On the OpenStack side, you talk about OpenStack more just as that you can present as a raw REST API, but do you actually have like a driver that you're going to push back into the OpenStack ecosystem? Or
yeah, we've got a Swift plugin as well as a Cinder plugin coming out. That'll be a part of our in the next 3 months. Those two pieces should be out. We also have our own S3 compatible object storage layer. Okay. So we can take any of our volumes and present it like it's an S3 storage layer, like an S3 bucket basically, or multiple buckets.
Seems like a rather expensive object storage pool. But typically object storage is what you throw on, that commodity, type of stuff, right?
Yeah, so here's what you could do. You could take a bunch of local disk, aggregate it, and not necessarily overlay memory on top of that, right?
Right. You could just treat it
that way. You could just treat it that way, and it'll still get deduplicated and compressed and all of that.
Right.
But you get just cheap, redundant object storage as well.
Right, and same way to manage it.
Yeah.
So what I've got here is a SQL database. It's got 8 CPUs and 16 gig of RAM. And I'm running HammerDB, which simulates a TPC benchmark. So pretty industry standard benchmark for running the capability within a system for a database workload. And you can see here that it's ramping up, but I'm delivering between 1.3 and 1.6 million transactions a minute. Now that, to give you some context behind that, if you look at the top 10 TPC benchmarks in the world, there's I think IBM or HP at number 10, and they're driving between 1.2 and 1.4 million for that benchmark. So the difference here is that I'm doing this off of 3 or 4 servers that are considered commodity hardware. They're spending probably millions of dollars to be able to drive that out of that benchmark process. And when you start to look at it, the performance is one thing, but it's the cost per transaction per minute that I'm actually getting back out of this. So each individual transaction is now costing me cents rather than tens of cents or even dollars in some instances. So it's 2 things. One is delivering the performance that SQL needs to be able to drive that data warehousing or whatever it is, and the other is then the cost to do that work is far less. So I'm getting both benefits for this workload. The second demo I'm going to show is, let me just
Our entire goal is after you leave this session, you're not going to be impressed by any vendor showing you an IOPS demo. That's really our goal today. So
I've got a friendly tool called Iometer, but I'm going to drive, the key here is that I'm actually being able to take a lot of distributed servers and take a very small amount of memory from each, 10 to 12 gig, and use that and combine that into a pool. So I can drive from these 20 odd servers, somewhere in the region of 1 million IOPS. So I can aggregate a lot of memory together to give me really good performance. Now if we look at what we're doing here, if we just close this clock, you can see that I'm delivering that at 1.4, 1.5 millisecond type latency.
And what kind of IOPS are these?
So this is driving 1.1. This is 8K, 60% read, fairly generic server type workload.
They're all probably zeros, and these CPUs compressing a lot to give us that kind of number, right?
No, they're not. So let me explain this piece. We actually use a version of Iometer that generates a 16 megabyte randomized buffer, fully randomized buffer. So every 16 megs that's generated, right, is done from a completely random source. Okay. So the deduplication compression you actually get across them is fairly horrendous. You don't really get a very high level. Probably about 1/3 of the entire data set is deduplicated and compressed. 2/3 essentially has to be moved around and committed around in different places. So I think this is 8K, 60% read, 40% write 80% random. Can you bring up the access spec, or?
Yeah, we can actually.
Yeah, let's bring up the access spec.
That's actually doing 4K.
Right, it's 80% right, 4K, which is even smaller, and that's 80% random. So I mean, the whole point is you see a lot of benchmarks with the iometer where somebody does a 512 byte, 100% read and says, I just did 1 million IOPS with a latency of 800 microseconds. Well, this is what an application more or less does. So let's really look at what that is.
What about if you increase that to 64K? What would it look like?
Well, let's find out.
Yeah. SQL or something like that.
Yeah, SQL or something like that, right?
Change the read write as well.
Yeah, why not?
You're using memory across multiple nodes here?
Yeah, in this case, 10 nodes.
Okay, is it striped? Is it?
So we use an erasure code placement for data. And so that essentially means that it's using some element of content awareness to place data out instead of just randomly hashing and putting things in different places. So if you look at most of these systems that are trying to do scale out storage, yeah, it's still a 1.3.
But what I guess what I'm asking is, what happens if your host fails during this test?
You need to have a certain number of hosts still running. So it boils down to a failure domain that is configurable, right? But for this particular domain, as long as 3 hosts are running, your data is fully protected. So you can lose 7, right?
What's the maximum that you can actually add to the pool on the hypervisor side?
We can scale to 256 nodes, and that's sort of an artificial limit that we put from a support standpoint. We can actually scale out more if you've got network bandwidth. The hypervisor itself has some limitations around cluster size, for example. I don't know what it is right now in the latest version.
I think it's 32.
32, yeah, 32 in a cluster. But you'll have to split them over multiple clusters then.
Right, okay.
Yeah.
Is there a concept of like most frequently used and most recently used in the what gets stored in the RAM? So when you're done with this database I/O, maybe it doesn't deserve to be in your RAM.
Yeah, so if you've chosen the hybrid model, it does get delegated down back to cold storage or spinning disk at some point. We essentially use is deduplication and frequency of block change to compute those things. It's not necessarily the number of times a block was accessed. It's the rate of change of the block that we use to actually place things in our hybrid cache. So sorry, go ahead.
The point of this demo is really show you what happens if we want more I/O and bring in more resource. So I can actually make some calls to backend through, again, a REST API and come back and see that you've actually started to see additional resource come into this iometer. Now, one of the caveats here is I just need to create a new or a second stage. So bring in and tell how to drive that. And it's going to go back to 4K. So go back to the 1.2 million IOPS. If you set this running again, you can now see that I've just doubled the amount of I/O that I can deliver to this application. So I'm now delivering 2.3 million IOPS. So a lot of this is the ability to, add and remove capability and policy-driven storage to be able to drive I/O to what the application needs, rather than typically, you put a bit of storage in the corner and say, it can give me 40,000 IOPS. Now am I going to use it? Well, now I can react to what my application really needs.
So I just want to put this in context, because when you start throwing millions of IOPS out there, it all just sort of jams together and looks like one number. This is 20 or 25 extreme IO X bricks, right, required to drive this kind of IO. And we're talking about a very highly randomized workload. And that was just done in complete software. We expanded the cluster dynamically in software with one REST call. And so you essentially in your data center, you can take assets that are sitting around underutilized and start pulling resources in from there and delivering this. So that's the world that we're trying to paint and help customers build into. This notion of software essentially making storage a very liquid asset that can be pulled and pushed and molded into whatever it needs to be from an application perspective.
How are you licensed?
I'll let Seth answer that one.
That's a good question. On licensing, even beyond your product, what's the underlying licensing at the hypervisor layer? So at VMware, all of the work that you guys do eliminates the need for us to be running network, storage I/O control and all that stuff, because it's happening in your layer, not down at the hypervisor layer. So effectively, do we still need to be licensed there as well as in your product suite?
Yeah. So you can put storage I/O control on top of us, although I don't know why you'd want to do that. But where things will get interesting is that we will expose our ADS volumes as vvol controllable volumes. So the definitions can be extracted automatically through the metadata we provide. So I think at that point you will end up needing those features from VMware anyway, right? because it's a big part of what we want to do, which is essentially allow VMware to orchestrate this entire framework, be vVol compliant, provide all the metadata and the tags that are required to drive all that. So you'll need those features anyway.
And you don't want to get disinvited from PAX.
No, we'd rather do joint blogs about extending vSAN at PEX like we did.
About height availability, you have told about full domain that you can choose. You can choose which host go to which group of hosts. For example, you put in a rack a group of hosts, and in other you can build.
Essentially. So you can essentially build these MS to N failover models. So you can pick a pool of hosts and a pool of nodes that are a part of USX, and say you can fail over to any of these. And so a single node, it can essentially take on multiple roles in a failure scenario. So it's very flexible. It's not a very rigid 1:1 or an N+1 model. It sort of uses whatever resources are available to fall over. And it can do that at the aggregator level where the storage paths are. It can do that at the pool level where the storage is consolidated, and it can do that at the individual volume level, right?
It's possible build metro cluster.
Those are roadmap bits. I'll talk to you in 6 months, and we'll show you some of what's coming out there. So it'll be some interesting bits there for sure.
So a 10 gig infrastructure is needed for this, right?
Yeah, it's a prerequisite.
In a converged infrastructure, do you have to segment a certain traffic pattern through? Do you have to put some I/O QoS on it to effectively have it work right?
It helps. So it's essentially something that is a recommendation. It's not done as it's not enforced. But essentially, just having a separation of VLAN level between these pieces will help out. Quite a bit.
That's the minimum.
That's the minimum. Okay. Yeah, but a 10 gig is prereq for any kind of production usage for us.
Yeah, of course.
Right. Yeah.
A question came from a couple folks in the community. Do you guys mind sharing your workloads that you guys put in IOmeter, the workload profiles? That would be really cool, because it's a great benchmark that we could use against our own stuff just to do sort of an A/B measurement.
Yeah, absolutely. We'd be very happy to provide all the details of the IOmeter workload. And give you that. Yeah.
Yeah, there's already a blog written by Jim Moyle that's desktop about how to do iometer with desktop, where we actually publish the test file for iometer and some, kind of guidance on that. But we haven't done it on the server side yet, so that's a good addition to the blogs.
Yeah. Any other general Q&A? I think we'll sort of open up the Q&A section.
Obviously, there's the underlying VM that's on each one of the hosts as well. The VM has to be running. If somebody powers it off or tries to vMotion it or whatever, this all is a problem.
Yeah, so there are protection schemes that you can define in ESX, for example, for VM power offs, etc. So we have a set of best practices for all of that. Yes, you are vulnerable because it is a VM and people can do stupid things with the VM. But then there are other built-in mechanisms. For example, the aggregators that are taking local memory or local storage, because they're on local storage, they're not vMotionable. So they automatically step out of the DRS group and things like that. And again, you define the level of redundancy you want. If you want a high level of redundancy, you obviously tend to spread a lot more data across a lot more nodes, and so you get a far more granular fault domain. Whereas if you're playing a little more fast and loose, you can change that. You can change that threshold.
Okay.
Do you have any concerns that VMware may try and do something similar, or other companies like Microsoft will do in memory, where they're currently maybe using this SSD tier plus the kind of capacity tier, that they'll start to do similar things to you guys and basically follow in your footsteps, so to speak?
I hope so. If you looked at us 4 or 5 years back, and 3 years back, or 4 years back, we were the first guys to come out and say, storage optimization for VDI. And now that's sort of become a mini industry in its own right. There's all kinds of companies that are doing storage optimization for VDI. So I think that if it's a successful product, you will naturally see competition come in and try and extend gaps that we have. By no means do we think this is the cure for cancer, cure for storage cancer. It might be, a cure for a large amount of it. So I think there will be gaps, and they will address those gaps. But I think there's an opportunity for us to partner the likes of Microsoft and VMware more and more as we bring some really new things into their platform that add value to their platforms. It's a natural migration of value from one end to the other end that we're enabling for them.
Yeah, that's right. And what you get to see today is a platform. You'll see, and Chetan I think touched on that. You're going to see us deliver a number of applications on top of that platform to optimize things between private data centers, between private and public data centers, the cloud, and so forth. So there's a whole new set of applications coming on top of that platform this year and next year that will fully extend, again, what the Microsoft and the VMware data centers look like. Even with technology that will allow you to work and combine data centers on different hypervisors. Mm-hmm. So there's a lot of work, and as Chetan said, right, the opportunity to, in partnership, to do more together is all to the benefit of our customers.
Thank you. Thanks.
All right.
Anything else? Was this
come back for more? I mean, obviously, there's going to be a lot of questions that have come back out of the community for this stuff. What's the right way to reach out to your team to find out more information and any other stuff that we can share?
Your demos.
Yeah.
I saw some of your stuff. You guys actually have a couple of great demos, and some of the stuff that you did there actually was on YouTube from very recently, right? It was actually a couple of weeks ago. I think that went up. Or like a month ago. Yeah.
Yeah, the one from PEX. Yeah.
We're doing a sort of a technical community embrace. And that's sort of been historically a little bit of our success has also come from the fact that we went early on to the technical press, the bloggers, and work, help them get it, get this and then talk about it. So we're happy at, I think that program's maybe 60, 90 days out, but to provide a free version of the software for people who are in the community who blog and write about interesting storage technology, we can provide that. We're going to do a series of very deep technical webinars specifically for storage enthusiasts, to get at that level that I was talking about, around these problems, rather than, the usual marketecture bullshit that a lot of people do. So we'll do a lot of that. But Greg, our VP of marketing, really does a great outreach and talks to a lot of people in an authentic voice, as I like. So, Greg, what do you think are the different intersections?
Yeah, so I gave my card to everybody. I welcome, any follow-on questions. I'm also on Twitter as well, at @gholzrichter. So, feel free to follow, and I can, DM you. As we say, we're here to actually answer your questions. It's been a great session, fantastic, really smart questions. We really do think that we have a very different way of solving this problem. And so, a variety of smaller startups have come up in the conversation. I think one of the things we want to reiterate is the fact we have, 500,000 plus installed VMs and almost, over 450 customers deployed at scale. So this is not a Series A first version that's going out there. So we really do feel like we have a different starting point to solve this problem. And so we're really, looking forward to bringing more of this out, talking to more, telling you about some of these additional customers that are deploying, case studies, putting it in your lab. So we look forward to it. It's going to be a really exciting year.
But when is it available?
Sorry, Marco.
But when is it available?
Yeah, so I know that.
When and how much? Two great questions.
Yeah. On the price, the base platform is available with pricing that has to do with the per amount of gigabyte optimized. So you'll see. In terms of that range, you see a range of $3 to $9 right now. We let our channel partner, we mentioned over 92% is through the channel. We let the channel partner set the price in the market. We give them a transfer price, and that's why you have a wide range of stuff that you see out there, even with ILIO today. So it worked really well for us. They buy from us at a price, and then they mark it up any way they want. It's based on the cost savings ultimately that the customer make. The product is available today. We make it available in a restricted release. We work with our key customers first. If you have a customer, or if you wanted to, we could work with you as well. It'll go full throttle early April.
Early April.
Early April. April 1st, April 2nd. They want to say April 1st.
Okay.
All right.
Was this useful?
Yeah.
Great. Thank you.
Yeah.
Very good. Well,
okay, so one of the things we talked about earlier was why would you buy vSAN if you're going to do this? Back to it.
It's a lot about customer choices ultimately, right? If a VMware customer choose or was provided or has bought vSAN, we can help him get more out of it. And that's the collaboration with VMware that we've gone through.
I might use one analogy to explain this. You know, VMware would, I think, try to charge for vMotion in the early days, right? And I look at vSAN as one of those features that's like vMotion. It's obvious in hindsight that something like this is just so damn useful, and it should have been there in the first place. So I don't expect it to be something they're going to charge up for a very long time. Let me put it that way.
I will agree.
Can use the example of the vSAN, the VSA. VSA was with initial fee. Then the fee was included in some package, and
So, but I guess I still. What does vSAN do that you don't?
Yeah, that's a great question.
So
okay,
as
VMware.
But that's still, I don't care.
I think the value is you have very easy built into the hypervisor, potentially less resource use by doing that, by building it into the hypervisor, that you can do the pooling of the local disk, right? So if it's good at doing that, we can do that too, but we have to put a VM there, and you are deploying extra VMs there, you're taking some CPU cycles, right? If that can be done more efficiently by VMware, and there's no cost as part of the hypervisor, then why not use that,
Except
right?
there will be a cost.
Yes, there may be a cost. They haven't announced the cost or price structure, right?
They've said that that's going to be a separate
Maybe on
SKU.
Thursday.
But so that they haven't said it's going to have a cost, but they said it's going to be a separate SKU.
Yes, yes.
Which implies that it's going to have a cost associated with it.
Yes. So obviously how widely it's used is going to be dependent on the cost, right?
Yes.
So it's going to be the customer's choice whether they want to use it to do local aggregation, and whether the value of that is in line with their cost, or whether, you know.
So you're saying if you want to use local storage, you better use vSAN, or?
No, you can use local storage, or you could use local like flash or local RAM or local disk, and you can leverage us to do the pooling and aggregation. Or if vSAN does that part more efficiently, use vSAN, and then we'll aggregate it and pool it and optimize it.
Look, at the end, it's very simple. We think vSAN is a really good. It's going to be a really well integrated product in the ESX platform. There are many things that we can do, but at a cost of configuration administratively that's a little bit higher possibly, but we really think it's a really good product. We think it's a really good initiative, and we thought that with ILIO we could extend how vSAN could be used in an enterprise by either now aggregating RAM and other flash technology with it, or any SAN NAS environment you have, and really bring this at enterprise class. So we really embraced it because we think it's going to be in a lot of places. We're going to find it everywhere, and we allow those VMware customers to now extend it or reinforce it with RAM or other local flash technology. And so that's kind of how we look at it. But if a customer is a Microsoft customer, if the customer has Zen server, then we can allow him to do the same thing. It will be less transparent, most likely, but it will have the same outcome.
Okay. So it sounds like you're saying maybe there wouldn't be a great use case to go out and buy both, but vSAN being there doesn't negate your value.
Well, in fact, I think there's some really good use cases for doing both. For example, if you are going out there and trying to build a storage infrastructure that's about a petabyte in size, right? You're going to need a lot of nodes to get over there. So we can essentially shave off a lot of the CapEx cost and take the already low cost of vSAN and make it even lower. As a cap. So I think there's lots of use cases where we can balance out the performance along with vSAN's capacity to allow you to have actually a very well balanced system between performance and capacity.
Yeah, and if you look at the test numbers, we were amplifying the IOPS available from a very small vSAN cluster to 120,000 IOPS, right? So if you have an application that needs that kind of IOPS but not tremendous capacity, or if you have new vSAN's going to have a specific disk configuration required, right? So it's mostly going to be new build out of things where you're buying new servers with vSAN, but your existing servers may not have that disk config. Maybe you can pool and aggregate those with us, combine it with the new vSAN, and you get a larger capacity pool.
So basically we look at vSAN as a brick that we can include as a storage component.
Of course.
Yeah.
Very good. Thank you all. Really appreciate the time today. We understand the time is coming to an end, so thanks a lot. Appreciate the opportunity.
Thank you.
Thank you.
Thank you. Our pleasure.
Thank you.